Okay, good morning everyone. We are going to do quarter 3 review today. So we'll be focusing mainly on right triangles, trigonometry, etc. But we'll start with a problem of the kind that we did earlier in the quarter involving areas, the relationship that holds between areas of similar triangles. So as I read the problem, I will make myself an annotated diagram, and you should do the same. ACE is similar to BDF. That means AC corresponds to BD. The area of ACE is 20 centimeters squared, and the area of BDF is 5 centimeters squared. Length of AC is 5 centimeters. What is the length of BD? Okay, turns out there are two ways of thinking about it, and I will show you both ways, and you can just stick with the one that makes more sense to you. So first approach is to determine the scale factor that would map ACE onto BDF. Let's call that S. So S represents the scale factor that maps ACE onto BDF. And the reason why that's helpful is because if we know that scale factor, we can use it to multiply the length of AC by that scale factor, and we will obtain the length of BD because those two sides correspond. Okay. The second thing to remember is that let me write that down as well. The area of ACE times the square of the scale factor, for mapping this onto that, is going to give us the area of BDF. So we can use that to write the following equation. 20 times S squared, very important to remember to square, is going to be equal to 5. Divide both sides by 20. And we can simplify this fraction as 1/4. So then S is the square root of 1/4, which is half. Yeah, we're not quite done because we weren't asked to find the scale factor, rather we are looking for the length of BD. Now we know that the length of BD is going to be equal to the length of AC times the scale factor. So it's 1/2 times the length of AC. So that is 1/2 times 5, which is 2.5. So BD is 2.5 centimeters. Okay, if that made sense to you, that's great. You can just skip ahead. If not, you can listen to this other way of figuring this out. So instead of thinking about the scale factor for mapping ACE onto BDF, we can just directly find the length of BD. It's possible. Now we need to remember how the ratios of sides of similar triangles are related to the ratio of areas. Now so let me just first define the variable. X represents length of BD. And if you remember, the square of the ratio of corresponding sides, so we need to square this quantity, is going to be equal to the ratio of areas. Right, so we can use this to write the following equation. X, well, BD corresponds to AC, so X over 5, we need to remember to square this, is equal to the ratio of the areas, so that is 5 over 20. Now, the other thing that I would like to draw your attention to is the fact that because the numerator here is a length of a side of triangle BDF, the numerator here should also involve triangle BDF, and in fact it is the area of BDF, right? So okay, now we are going to multiply, square the left hand side. So it's going to be x squared over 25 is 5 over 20. Simplifying, that's 1/4. Multiply both sides by 25. It will be x squared is equal to 25 divided by 4. You can also cross multiply. You will see that you get the same thing. Okay, so x is equal to the square root of 25 over 4, which is 5 over 2, also known as 2.5, which is exactly what we had gotten before. So either method is totally fine, and you can choose the one you like. One last note before we go to the next problem is how are these two related, right? In case you're curious about that. So starting with this equation here, suppose we multiply both sides by 20, right? We will get 20 times x over 5 quantity squared is equal to 5 over 20 times 20 is just 5. Now compare that to what we had started out with over here. They're essentially the same. You have the 20 and the 20 and the 5 and the 5. That means this s squared here is the same as this x over 5 quantity squared, and that makes sense because the ratio of the corresponding sides is another way of referring to the scale factor. Okay, so that was our first problem. Second problem is this. We have this word problem. They gave us the diagram already, which makes it a little easier. But let's just read through it and see what we have. A wire attached to the top of the tower, here is a cell phone tower, makes an angle of 65 degrees with the ground. So this is 65 degrees. From a point on the ground, 100 feet from the end of the wire, so this point over here is 100 feet away from the wire, the angle of elevation to the top of the tower is 32 degrees. So this angle is 32. What is the height of the tower to the nearest foot? So they're asking us to figure out the height of the tower, which is this. So suppose we say that that is x. X represents the height of the tower. Now, as you can see, there are two right triangles. So let's call the small one ABC. And let's call the larger one ABD. And you may be tempted to use one of the trig functions because, these are right triangles, and that's, when we have right triangles, we use the trig functions. And specifically, you may try to use tangent because we are asked about one of the legs of this triangle, right? However, if you use that, you will see your equation will have two unknowns, and that is because in order to use the tangent function, you need to know the measurement of at least one of the legs, which we don't have here. DC over here is not a leg of either of the right triangles, right? So the tangent strategy is not going to work out. So what are we going to do? Well, the first thing I'm going to do is figure out these angle measures here. So suppose this one is M, and then this one is N. Okay. Now, looking at this smaller triangle, ABC, I know that the two acute angles, because it's a right triangle, the two acute angles are going to be complementary, which means they add up to 90 degrees. So if this is 60, that means M is going to be 25 degrees. Okay. Same kind of idea for the bigger right triangle. In ABD, D and A are complementary, right? They add up to 90. We can write that down. Measure of D plus measure of angle DAB is, can you see? Yeah, is 90 degrees. But then DAB is composed of these two angles, with measures M and N. So let's write that down. D is 32. M we just figured out is 25. So what is N going to be? Well, these two right over here is 57. So N is equal to 90 minus 57, which is equal to 33 degrees. Okay, we made a lot of progress. That's 33 degrees. Now, the first thing we need to do is, we still don't have enough information to just go directly for the length of AB. So we need to consider this non-right triangle here, which is ACD. Now, it's important that this is not a right triangle, so we cannot just apply one of the trig functions. Instead, we know these two angles. We know the length of this side that's opposite to this angle, and it would be really helpful if we can figure out the length of AC, because AC is the hypotenuse of ABC, because once we have the hypotenuse, we can then figure out x, right? So that is what we are going to do. Now, so for figuring out y, we know it has to be either the law of sine or cosine, right? Because it's not non-right triangle. And we can see that because we know these two angles and a side, and we're trying to find out the other side that's opposite to this angle, we can use the law of sine. So we can write this equation, sine 32. The side that's opposite to it is AC, whose length we are trying to figure out, is equal to sine 33 over the side opposite to that is DC, that's 100. Cross multiply, so 100 sine 32 is equal to y times sine 33. To isolate the y, divide both sides by sine 33. Put this into your calculator and you will get y is equal to 97.3 feet. Okay, that was y, but we are actually looking for x. So now let's focus on triangle ABC. We see that we know the hypotenuse and we're trying to find one of the legs. That means we need to use either sine or cosine. Either one would be fine. I will use sine. So we can do sine. Sine, by the way, just a reminder, is defined as opposite over hypotenuse. So opposite, AB is opposite to this angle. So sine of 65 is equal to x over the hypotenuse we just figured out was 97.3. So x is equal to 97.3 times sine 65. If you put that in your calculator, you will get 88.2, I believe. But they told us to round to the nearest foot. Please pay attention to how they're asking you to round. So the height of tower is 88 feet. Okay, so the next problem, you should pause the video and do the next one by yourself, and we will quickly check our answer. So I imagine you tried it, and we're just going to quickly have a look. It says, okay, here is the right triangle ABC, where C is the right angle, and then this is the altitude, this is one altitude of triangle ABC. Figure out the length of CD. So what we need to do is to remember that, I will write this down here, that CD is the short leg of the medium triangle being BCD, and it is the long leg of the small triangle. So we are going to make a little chart. We're going to do short leg. I hope you can see that. Long leg and hypotenuse. And small triangle and medium triangle. Turns out you don't really need to try to fill everything out. Okay, so CD is the short leg of the medium triangle, so it goes over here. And the long leg of the medium triangle, that's BD, that's 12 units. Long leg of the small triangle is CD, so that is, excuse me, that's AD, so that's 3. And the long leg of the small triangle is CD, so that's X. We have enough information now in our chart because we have information about 2 pairs of corresponding sides. So we can write the proportion and cross multiplying, you'll get x squared is equal to 36. So x is 6. So CD is 6 units. Okay, that was all for today.